Subtraction of surds. Next, we're working with subtraction of surds. Let's say you have 2 root 2 minus root 2. Subtraction of surds also works similarly like you're working with algebra. Let's say root 2 is a. So you have 2a minus a. You can say 2a minus 1a. 2a minus 1a is 1a, or you can say it's also the same thing as a, because if you have 2a minus 1a, you pick one of the a's, then you do 2 minus 1, it will give you 1. Same applies to when you're working with subtraction of surds. This is also 1 root 2. 1 root 2. So you pick one of the root 2's, then you have 2 minus 1. 2 minus 1 is 1. So the same thing as 1 root 2. Better, we can still say the answer is root 2. That's for the first question. For the second question, you have root 2 minus 2 root 2. Like I said earlier, the root 2 has a 1 in front of it, though it's not written. You have it as 1 root 2 minus 2 root 2. Since they are like terms or they are similar surds, you pick one of the root 2's. You have root 2, then you have the whole numbers, which is 1 minus 2. 1 minus 2, at this level you can use your calculator. 1 minus 2 is minus 1. The answer to 1 minus 2 will give you minus 1. So we can say minus 1 root 2, or we can say minus root 2, same thing. So you can have your answer as minus 1 root 2 or minus root 2. We go to the third question where we have 2 root 2 minus 3 root 3. This can be compared to subtracting algebra, where you have root 2 as a and root 3 as b. So you are like having 2a minus 3b. If you have 2a minus 3b, since they are not like terms, you can't do anything to this. This is just your answer. Same applies to surds, where you have root 2 and root 3. They are not like terms or they are not similar surds, so you can't do anything to them as regards subtracting. So you have your answer as still 2 root 2 minus 3 root 3, because they are not similar surds. We go to the fourth question, where we have 4 root 2 minus 3 root 3 minus 2 root 2 minus 4 root 3. Similar to algebra too, we collect like terms or similar surds. We will start with the root 2's. We collect them together first. We have 4 root 2. The next root 2 we have is 2 root 2, but this is not just 2 root 2. This 2 root 2 owns this minus, so we are moving it with the negative. So we have minus 2 root 2. Then we have 3 root 3 with the minus, so we have negative 3 root 3. Then lastly we have minus 4 root 3 minus 4 root 3. We've collected similar surds, and in some cases they call them like terms. So we have 4 root 2 minus 2 root 2. You pick one of the root 2's. Then you have 4 minus 2, that's 2. On this other part, you have minus 3 root 3. This 3 owns this minus. You have to be careful here. This is one of the mistakes students make in math. So we have not just 3 root 3, minus 3 root 3, minus 4 root 3. You pick the root 3 first. You don't jump on the sign. It might be negative, it might be positive. Then you add the whole numbers together, which is minus 3 minus 4. You are owing 3 and you are owing 4. You are owing 7 in total. You don't have anything. That's minus 7. So you have this as minus 7 root 3. So our answer, since root 2 and root 3 are not similar surds or they are not like terms, you have your answer as 2 root 2 minus 7 root 3. Final answer. We have our last question, which is question 5, as square root of 45 minus square root of 20. Both of them are surds in their single form. So we'll break them down into their basic form and see if they are like terms and if we can subtract. We have square root of 45 as 9 times 5. This 9 represents the highest perfect square that can go in 45 without a remainder. Then minus, in the other root, we have 20 as 4 times 5. 4 is the highest perfect square that can go in 20, so we have 4 times 5. At this point, we give them their separate square roots. We have square root of 9 times square root of 5, since they are linked by times, minus square root of 4 times square root of 5. Square root of 9 is 3 times root 5. Square root of 5 gives a decimal, so you leave it as root 5. And since it's linked to his root 9, which value is 3, you can join them together. You have 3 root 5 minus square root of 4 is 2. If you find square root of 5, it gives a decimal and is linked to this value by times, so you just join it to the root 2. So you have it as 2 root 5. Then you have 3 root 5 minus 2 root 5. Both of them are similar surds or like terms. You pick one of the root 5s, since they are the same, then you do 3 minus 2. 3 minus 2 is 1. So you have it as 1 root 5, which you could also say is just root 5 as our final answer.